Rare earthquake struck in the Gulf of Mexico today. The U.S. Geological Survey reporting a 4.6 magnitude quake about 160 miles southeast of New Orleans at a depth of 6 miles.
Beneath the calm blue surface of the Gulf of America, disaster struck with barely a warning. In one extraordinary moment, the seabed itself shifted, unleashing an underwater avalanche of immense power. Now an entire region of ocean, vital to America's economy and coastline, has been sealed off by US authorities. The world's eyes are fixed on the Gulf's horizon, wondering what secrets lie beneath those suddenly forbidden waves. What set off this chain reaction? Why did the nation move so quickly to shutter one of its most important maritime corridors? And what does this abrupt shutdown reveal about the hidden forces shaping not just the Gulf, but the very crust beneath our feet? Today, we're diving deep into a mysterious geological event, exploring every rupture, every quake, every echo rumbling through Earth's crust. This is the untold story of the Gulf of America's sudden crisis, one that reverberates far beyond the water's edge. Because when the seafloor fails, everything above it is put to the test. So just how close are we to the next big break? Let's find out. Chapter 1. Undersea Collapse. Shockwaves. It started quietly. A faint vibration rippled through the ocean floor, undetectable to most, but registered on sensitive seismographs. Then, in an instant, that tremor escalated. The sea floor, once thought immovable, began to tilt, slide, and fall. Masses of sediment, rock, and ancient deposits raced down slope in a destructive cascade. A full-blown underwater avalanche. How do underwater avalanches form, and why are they often more perilous than their landlocked cousins? Unlike landslides that scar the surface, underwater avalanches, also known as submarine landslides, exploit the ocean's hidden topography. Subtle shifts, changes in pressure, or seismic nudge can unleash billions of tons of material. Waterlogged sediment, held together by pressure, suddenly gives way and turns fluid with astonishing speed. The result? A wall of mud, sand, and stone barrels along the sea floor at speeds that can reach up to 100 kilometers per hour. These flows are silent, unstoppable, and typically offer no warning above the surface. For ships and infrastructure overhead, there's nothing to see until the event is already underway. These undersea events don't just stop at the ocean floor. The force they generate often pushes upward, altering water pressures and spawning unpredictable currents that may disturb the surface. Local fishermen, attuned to subtle changes, sometimes notice odd upwellings or discolored water before the news breaks. Instruments on distant oil platforms may register mysterious sways or vibrations, hinting at chaos below. In the Gulf of America, marine research teams operating remotely piloted vehicles reported a sudden, unexplained turbidity, an underwater blizzard of silt, just hours before the official shutdown. Such signs, easily overlooked, are part of the sea's hidden language, one still poorly understood by those who depend on the Gulf for their livelihoods. The true scale of these events and what triggered them here is now the urgent question facing scientists and officials. Did a subtle earthquake tip the balance? One that wouldn't be noticed in a city, but spells disaster on the active, shifting bed of the Gulf? Or did pockets of methane gas trapped below the sea floor destabilize the sediments, transforming stable mud into a watery slurry? Scientists are combing through data and core samples, reconstructing the blink and you'll miss it sequence that led to the Gulf's upheaval. Chapter 2. America's maritime lifeline cut. Imagine the jugular vein of American commerce abruptly clamped shut. That is now reality, with authorities invoking a sweeping closure of the Gulf of America. The Gulf isn't just a deep blue expanse. It's home to busy shipping lanes, energy platforms, and major fisheries, serving as the gateway to the nation's southern coast. In an instant, this lifeline snapped. Cargo containers sat idle in harbours, oil rigs powered down, crews evacuated. The heartbeat of Gulf trade stilled. Why would a single geological event prompt such a drastic action from the US government? The answer is in the scale and unpredictability of underwater avalanches. Unlike surface disasters, these phenomena directly threaten buried infrastructure, oil pipelines, communication cables, and offshore rigs. When the seafloor rearranges itself, it can snap pipelines, topple platforms, and render huge investments worthless. This collapse proved how quickly nature can erase even the best-laid human designs. With so much at stake, the only rational response was to retreat fast. The economic consequences reach far inland. Houston's port gates shut, oil tankers idled at anchor, unable to load or unload. Shrimping fleets, a vital part of coastal communities, were recalled amid fears that seafloor instability could disable smaller vessels. Tourist towns from Texas to Florida watched in shock as cruise ships rerouted far out to sea. Insurance markets responded with spikes in premiums for operations anywhere near the Gulf corridor, reflecting the sudden rise in risk. In the information vacuum that followed the closure, conspiracy theories and rumors flooded social media. The federal government moved to reassure the public, pledging transparency and support for affected businesses and communities. But anxiety lingered. Was this event a one-off or a sign that the Gulf has changed for good? Chapter 3. The Seafloor Failure Code. Beneath the Gulf's waters, the floor is anything but solid. It's a patchwork of river deltas, soft sediments, and hidden faults. A volatile mix waiting for a trigger. How do scientists unravel the secrets of an ocean floor that can buckle overnight? Modern geology employs a suite of tools. Echo-sounding devices map the topography, seismographs detect rumbles, and core samples taken from the deep preserve the story of past avalanches. Layers of mud deposited in a geological instant. Underwater drones monitor temperature, chemistry, and currents far beyond human reach. Researchers use satellite gravimetry to watch for minuscule changes in Earth's gravity, signaling movement of massive underwater material. Academic and industrial partnerships help piece together the Gulf's ancient catastrophes, using chemical tracers and isotopes to date layers and match them to prehistoric landslides and flooding. In the Gulf, these investigative tools point to a region under mounting stress. Each new fault or anomaly adds to the puzzle. The question remains, is this failure the result of centuries of gradual build-up, or the unpredictable consequence of a recent, singular shock? Chapter 4. Earthquakes write the next line. We often think only land harbours seismic danger, but Earth's crust is restless everywhere. Its plates push and pull, flex and fracture beneath both continents and seas. In the Gulf of America, recent tremors have rewritten the region's reputation for geological calm. Some have been strong enough to rearrange miles of seabed, kicking off avalanches and shifting pressure in ways models struggle to predict. Are underwater earthquakes the real driver of these underwater disasters? Geologists confirm when fault lines slip underwater, shaking can quickly loosen centuries of sediment. Even modest quakes may shift enough material that gravity overtakes cohesion, unleashing destructive flows. Underwater, seismic shock travels faster and farther, shaking far-flung stretches of the continental shelf. Swarms of tiny quakes, unremarked in the media, can still act as early warnings for geologists. Seafloor sensors now send real-time data to labs across the country, fueling a race to forecast and perhaps even to prevent the next major failure. The lesson is clear. Even small, unremarkable tremors can, under the right conditions, have enormous consequences underwater. Chapter 5. Faults beneath the surface. Beneath the Gulf's soft sediments lie buried faults, breaks in Earth's crust that can linger for eons before suddenly coming alive. While the dramatic faults of places like California often steal the spotlight in popular imagination, many of the Gulf's own fractures remain only partially understood. Why do certain faults in or near the Gulf provoke such concern for geologists? because motion along these deep structures can reshape both land and seafloor, sometimes triggering eruptions of instability far from their visible scars. Hidden faults can transfer energy over large distances, priming regions for disaster. As new tremors and minor swarms are detected, it is clear that the Gulf is not isolated, but intimately connected to broader tectonic happenings. Each shifting plate or crack a reminder that the region's serenity is merely an illusion. Recent mapping and analysis have revealed mineral deposits and signs of ancient seismic events that may trace paths of these buried faults. Each new project, each pass of the seismograph helps bring into focus the Gulf's tangled geologic foundation and possible future risks. Chapter 6: Underwater Avalanche Mechanics. Disaster underwater unfolds not with a roar, but a surge. When an avalanche starts below the sea, its violence is often far greater than its terrestrial counterparts. What transforms stable seafloor sediment into a deadly force? Science points to liquefaction, a process in which saturated mud and sand lose their strength in response to vibrations or shock, behaving suddenly like a liquid. Once friction is lost, slabs of sediment slide, scouring the bottom and pulverizing anything in their path. Submarine avalanches may travel immense distances, affecting regions far from their initial starting point. In places rich with oil, gas, and infrastructure, the damage multiplies. What's more, huge underwater avalanches have been traced not just to sudden quakes, but to slow processes, such as the seepage of gas, changes in sediment buildup, and shifting ocean currents. Even the gradual melting of methane hydrates as temperatures rise may play a part. Marine biologists sometimes note unexplained mass die-offs in deep-sea life ahead of collapses, possibly due to subtle shifts in pressure or water chemistry preceding the main event. In the labyrinthine canyons of the Gulf, avalanche mechanics play out on a scale both massive and minute, making prediction a formidable challenge for science. Chapter 7: Submerged Volcanic Threats. For centuries, volcanoes have reshaped the seafloor in many parts of the world. While the Gulf of America is not known as a volcanic hotspot, some recent findings have raised questions about possible ancient or obscure magmatic influences. Could unknown volcanic or geothermal activity be adding instability in the Gulf? Deep within Earth, upwellings of heat can weaken overlying crust and alter sediment stability. While evidence for active, traditional volcanoes in the Gulf is lacking, researchers have uncovered layers that include volcanic ash and signs of thermal anomalies consistent with hydrothermal activity. The possibility that these factors play a role in seafloor destabilization cannot be discounted, even if direct evidence of volcanic eruptions is yet to be confirmed for the Gulf. Research teams have documented thermal plumes, and some hydrothermal vents recently appeared in survey footage, spewing mineral-rich, heated water from the seabed. Such phenomena could further weaken sediments and contribute, in conjunction with other triggers, to major undersea slides. Chapter 8: Mapping the Gulf's submerged faults. Not every rupture is easy to spot. Many faults lay buried beneath layers of mud and sand, undetected and waiting. How do experts uncover and monitor these hidden threats? Advanced sonar and seismic imaging yield a three-dimensional portrait of the ocean floor. Subtle deformations and echoes help trace fault lines and other structural weaknesses invisible on the surface. Combined with ocean bottom seismometers, these tools provide near real-time data about ongoing shifts and pressures. Recent surveys have revealed new fault segments in the Gulf's most unstable areas. Projects led by NOAA, the USGS, and other agencies deploy instruments to build intricate digital maps, networks of intersecting faults, each with the potential to drive future disasters. The painstaking work of mapping is the best hope of catching an impending crisis before it unfolds. Chapter 9. Tsunami shadows lurking. Every underwater landslide carries a serious risk above the waves: tsunamis. These waves, generated by the sudden movement of ocean water, can devastate coastlines in minutes. What makes landslide-generated tsunamis especially dangerous for the Gulf? Unlike those triggered by distant earthquakes, local tsunamis from submarine avalanches arrive with almost no warning. As tons of sediment careen down the continental slope, the displaced water forms a pulse traveling rapidly across the sea. In enclosed regions like the Gulf, wave energy can be amplified by geography, focusing devastation on nearby shores. Computer simulations after similar events suggest that even smaller underwater slides can create significant waves, possibly exceeding 5 meters in certain bays or inlets. The Gulf's curving coastline means energy can reflect and concentrate, posing a special risk to cities, ports, and wildlife habitats. Historical records, including indigenous stories and early colonial documents, tell of walls of water sweeping inland, a clue that these rarely observed but potent events have shaped the region's past as well. Chapter 10. Infrastructure in the crosshairs. The Gulf of America is intertwined with human industry. Oil platforms rise from its waves, pipelines cross its muddy bottom, and cables connect it to the global internet. How vulnerable is this infrastructure to shifts in the seafloor? Unfortunately, submarine avalanches are indifferent to human achievement. Pipelines engineered to survive surface storms can shatter under the weight of moving sediment. Oil rigs may be destabilized or made unsafe. Submarine communication cables are at risk of being severed, which can disrupt international communications. Remotely operated vehicles have documented evidence of buckled pipelines and damaged platform supports in the aftermath of recent seafloor shifts. Crisis response teams are working to plug leaks, assess damage, and restore key connections, but the work is perilous and the area remains unstable. Environmental groups warn of long-term impacts. Oil slicks threaten ecosystems, and mud flows can choke coral reefs or create dead zones where few creatures survive. The economic ripple radiates outward, hitting supply chains, fuel supplies, and jobs across the southern United States. Chapter 11. Microplates and New Boundaries. Over millions of years, Earth's crust fractures and shifts, redrawing ocean floors and continents alike. Are microplates forming beneath the Gulf, and what risks could this bring? Seismic data show not just classic linear faults, but twisting ruptures, signs that small segments of crust may be moving independently. These microplates can intensify stress at their boundaries, setting up new fault systems and possibly increasing the chances for future underwater slides or quakes. Geologists compare this emerging activity to what's happened in places like the Mediterranean and the East African Rift. There, breaking crust set off centuries of volcanic and seismic instability before settling into new boundaries. In the Gulf, researchers use GPS buoys and precision altimeters to watch millimeter-scale seafloor motion, a process almost invisible in daily life, but dramatic across longer timescales. While a splitting ocean basin is a remote prospect, the shifting pattern signals ongoing change beneath the water. Chapter 12. Lessons from plate destruction. Earth has a history of lost and fractured plates, each leaving a legacy etched into the landscape. The slow destruction of gigantic plates in the Pacific and elsewhere shows how even the world's most massive structures are not eternal. What lessons do vanished tectonic plates offer in understanding today's Gulf emergency? When oceanic plates have ruptured or sunk into Earth's mantle, they created new faults, new ocean features, and unleashed waves of earthquakes for centuries after. The Gulf's evolving system offers similar warnings. What happened here may one day be seen as one chapter in a vast geologic transformation. While human lives are short, the memory of these events are written in the rocks and seafloor for millions of years. From fossilized trenches to uplifted ridgelines, The scars of plate destruction are everywhere if you know what to look for. Applied to the Gulf, these clues push researchers to stay fully alert for shifts, ruptures, and the long-term consequences of these seemingly isolated disasters.
Chapter 13. Panic, Preparation, and Stockpiling.
News of the closure and disaster spread fast, and so did fear. Reports of the Gulf shutdown, damage to infrastructure, and speculation about future risks caused anxiety. In many communities, grocery shelves emptied as families rushed to build emergency reserves. Does panic offer any advantage in a geologic crisis, or does it simply increase risk? The science is clear. To be ready for natural disasters, planning and preparedness matter. Stockpiling essential supplies and making evacuation plans can save lives. But panic can undermine coordination, clogging roads, straining supply chains, and impeding emergency responses. Understanding, not fear, is the key defense. Communities closest to the Gulf closure responded in diverse ways. While some focused on readiness, others fell prey to rumors. Emergency services and volunteer groups worked together, delivering supplies to the vulnerable and providing clear instructions for safety and response. Chapter 14. The New Risk Frontier. With the Gulf shuttered and its seafloor transformed, America faces a changed landscape. Yesterday's assumptions have been swept away. Coastal communities, industries, and scientists are evaluating how to adapt to a world where the ground itself may shift without warning. How should societies respond when natural stability can no longer be taken for granted? Governments, engineers, and researchers are re-examining everything from port design to emergency alert systems. Investments are being made in improved monitoring, combining satellites, ocean buoys, and underwater drones to feed data into real-time models. Academic centers are ramping up studies of coastal geology and disaster preparedness. Engineers are already proposing new standards for rebuilding infrastructure, incorporating flexible foundations, redundancies, and new risk insurance strategies. Public education sees a surge of interest in geology and emergency management, driven by a new sense of urgency. Plans to reopen parts of the Gulf are underway, but with new rules, oversight, and a recognition that living with Earth's natural volatility means constant vigilance and adaptation. Chapter 15. Awaiting the next signal. The sea above the Gulf of America is calm once more, but below lies a world irreversibly altered. Scientists continue to monitor, governments plan, and coastal communities remain alert. Each rattle of the seismograph, each unusual upwelling or unexplained tremor, pulls attention back to a region marked by disaster and renewal. The Gulf's closure is more than a cautionary tale. It's a glimpse into a future where Earth's hidden forces command respect. An avalanche, a quake, an overlooked layer of sediment may be all it takes to shift routine into emergency. But as long as we seek to learn, monitor, and adapt, hope endures. The Gulf of America's recent silence shelters a story that's just beginning, a reminder of our planet's restlessness and our own evolving understanding. If you want to hear more about Earth's secrets, the unseen dangers beneath our oceans, and how we prepare for what lies ahead, stay curious and stay prepared.